So I think it's fair to say that everyone found that test quite difficult. So I thought I'd go for a complete run through just to give everyone a chance to go back over the questions and understand how to get the right answers. Some of these you might have found easy, feel free to skip ahead. Start with simultaneous equations one. Whenever you've got a simultaneous equation where one of them is linear and one is non-linear, i.e. one is a straight line equation and the other one has x squared or xy or something like that in it, your standard tactic is to rearrange the linear so that one of them is the subject. In this case, y is already the subject, and substitute it into the non-linear. So that's your linear equation, that's your non-linear. This one's made slightly easier by the fact that y is already the subject of the linear and y is the subject of the non-linear. So you can literally replace y in the non-linear with 6x plus 10. So this becomes 6x plus 10 equals x squared plus 8x plus 2. And then, because it's a quadratic, you rearrange to make it equal to 0. So you get x squared plus 2x. Subtract 10 minus 8. This factorizes x plus 4, x minus 2. And so you've got x equals minus 4 or 2. Then you go back to the linear equation and you work out what the corresponding y values are. So y, obviously, when x is minus 4, is going to be minus 6 times minus 4, which is minus 24, plus 10 is minus 14. And y is 6 times 2 plus 10, which is 12 plus 10, which is 22. Be aware, though, that this is not a sufficient answer to get full marks. Whenever you have a simultaneous equation, you have to present the pairs of values as they go together. So when x is minus 4, y is minus 14, and that must be explicit. So you need to say x equals minus 4, y equals minus 14, or x equals 2, y equals 22. But most of you know that already. You got these questions in GCSE, they were just worth a few more marks. Solving an inequality. People struggled with this one. I think most people worked out that factorizing it and working out the values of x that made this 0 was a good thing. And so they quickly identified that x equals minus 2 and minus 5 were the crucial points. But from there, it all got a bit confused. This is a quadratic, and a positive quadratic because the x squared is positive, which means that it has this shape, right? Roughly. I should have thought about this better when I was working out where my axes were going to be. They're going to be here somewhere. It doesn't actually matter where the axes are. So if that bit does confuse you, you wouldn't need to draw the axes in. You could even just draw your U shape and draw the x-axis and not worry about the y-axis and say, we know that this U shape cuts the x-axis at minus 2 and minus 5. Okay? Now, the key thing about a positive quadratic is that positive quadratics are positive most of the time. I.e., if you look at this graph with the both axes on, or even this graph, these are the same thing, by the way. I just drew it without the y-axis in case you found that more confusing or more difficult to draw. This should go off a bit more like this. But for most values of x, when you plug them into this, the answer you get will be positive. In fact, it's almost always positive, apart from when it's not, when it's equal to 0, and that's at the roots, and then the bit in between the roots where it's negative. So between minus 5 and minus 2 is the only time that this function is negative. So if the question had been solve x squared plus 7x plus 10 is less than 0, the answer, less than 0, the answer would have been between minus 5 and minus 2, which is the answer that most people gave. But that's not the case in this question, because we're trying to find out when it's positive. And as we said, it's positive most of the time. It's positive above the top root and below the negative root. And you have to write those two regions separately. So x is either greater than minus 2 or x is less than minus 5. And those are two separate conditions. You can't put them together because x can't be greater than minus 2 and less than minus 5 at the same time. These two different types of solutions, the one I just crossed out here and the one that's the correct one, are often referred to as inside or outside solutions. When we're looking for a positive result, when it's greater than 0, we're looking for the values of x outside the roots. So greater than the top root, less than the bottom root, and that's the answer to this question. But if it's negative, then we're looking for between the roots, so between minus 5 and minus 2. The crucial thing is, if it's a positive quadratic, it's positive almost all the time, apart from between the roots. And so here, positive outside, above the top root and below the negative root. Below the lower root, not necessarily the negative root. This one, I think, pretty much everyone got right, so I won't dwell on it. You know that x squared plus 8x comes from x plus 4 squared, and since x plus 4 squared gives you x squared plus 8x plus 16, you need to minus 14 to make it work. That's all that needs to be said about that for the time being. Right, you are given the gradient function and you're asked to find the equation of the curve. So dy by dx is the differential of y, so it's coming from y equals, and to get to that point, you need to work out what would differentiate to get you 3 plus 3x minus x cubed. So what differentiates to make 3? 3x. What differentiates to make 3x? It's a half of 3x squared, so 3 over 2x squared, or however you want to write it. Again, what differentiates to make x cubed? Well, that's going to be a quarter x to the 4, and then we have the plus c, and it appears here and it doesn't appear in one of the later questions, and I'll explain why then. That plus c is important because if you differentiate this, obviously the 3x goes to 3, the 3 over 2x squared goes to 3x, the quarter x to the 4 goes to x to the 3, but any number that was added on would disappear, because if you had plus 6 or minus 22, when you differentiate that, you would get nothing. So we don't know what this is. We are, however, given some information about the curve that will tell us what this is, because we know that when x is 2, y is 5. So we now sub this point into this equation. We sub in y is 5, and we sub in x is 2. And we plug all those values in, and this will enable us to work out c. So we get 6 plus 6 minus 4 plus c. So that's 12, 8 plus c. And so c is minus 3. And then having worked out what c is, we can now substitute it back into the original equation, and note the fact that it says y equals. Some people did not write that and lost a mark because of it. So that is our final answer. Find the coordinates of the stationary points on the curve, y equals x cubed minus 4x squared minus 2x plus 7, and determine their nature. So 3 stages here. The first thing you're going to do is find the x coordinates, and then because it's the coordinates, you're going to find the corresponding y coordinates, and then determine their nature means to work out whether they're maximums or minimums. Most people lost marks on the last part because there is a particular way you have to determine whether or not they're a maximum or a minimum, and that involves doing the second differential. Let's start at the beginning. So we want to find the coordinates of the stationary points. Stationary points, of course, are where the gradient is 0. So we're going to differentiate this and put it equal to 0. So this becomes dy by dx equals 3x squared minus 8x minus 3. We're going to set that equal to 0, and you will either have spotted that it factorized or plugged it into your calculator and worked out that it becomes this. And so we get x is 3 or minus a third. Now, we know what x is, we need to know what y is, because that's where the coordinates come from. So we plug each of these values back into the original function. So when x is 3, we get y equals 3 cubed minus 4 times 3 squared minus 3 times 3 plus 7. And I think that came out as 11. And then x equals minus a third. This one comes out pretty horribly. I might have to look at my answers before to work out what this one was. Something like 207 over 23. Have I got the answer here? Hang on, I can pause this, can't I?